Hello, Alex Cole with BobCAD-CAM here. So in a previous video, we looked at the parallel cuts toolpath and what that motion looked like when cutting on a floor. What I want to do now is I want to expand into the parallel cuts toolpath and look at how we can use that toolpath to finish the walls or to cut the walls on this part. So the strategy is a little bit different, and sometimes the results that people initially get is misleading and they believe that they're using the wrong strategy altogether. So let's see if we can clarify some of those points and show you guys how that you can be successful using that on these walls. So first I'm going to add a multi-axis operation, parallel cuts, and I'm going to use a 1/4 inch ball and mill. And in the parameters for this operation, what I'm going to do is I'm going to set my drive surfaces to all of these walls here, including the top and bottom radiuses. So as I always recommend, the first thing we do with any toolpath when creating multi-axis is we handle that in stages. The first thing we do is we get the cut pattern, the pattern on the surface the way that we want, and then we start applying tilting strategies and gouge checking in a sequence like that, so that we break it down into steps and we can conquer to get that successful path one step at a time. So if I compute this right now, what we're going to see is we get a path where the lines are going in all different directions. It's not very favorable. It doesn't look right at all, to be honest. And that's okay. This is the first step. So what we're seeing is the result of this machining angle sections right here in the pattern group for this toolpath. So right now by default it sets to the machining angle in Z, and really what we need to do to get the pattern that we're looking for is if we use this constant Z option, we'll see that that basically just zeroes out the machining angle, and if we compute this path, that's going to drastically alter the pattern that we get on this part. So this now is handling nice Z-level steps on the part, and it gets us closer to what we're wanting. So the reason that we have those two options is if you're trying to machine something on a floor, then you would set it to the XY option here. Let me show you. You would be using the parallel option, which is going to set that to 90 degrees, and that's going to work really nice for flat surfaces. However, if we're working on wall type surfaces, we want to use that constant Z option. Now you can manually configure the values that are in these fields as well, but these two quick select buttons just help us get to what we need based on the type of work we're trying to do. So looking at this path, we have nice motion on the surfaces that we're looking for, but if we backplot this and we look at this, our tool, okay, is not necessarily going to do what we want it to do. It is staying perpendicular to the contact point on the surface. There's nothing wrong with that. However, as it works its way down, we can already see that this tool is tilted way too far down, and we're going to be crashing into parts or fixturing or whatnot. So we don't necessarily want the tool cutting perpendicular to that surface. So this is where we need to start looking at our tool axis control options to correct this. So the system defaults to be tilted relative to cutting direction, and right now the lead lag and side tilt is both set to 0. That's why that tool is staying perpendicular to the point that it's contacting on that surface. So this isn't the option that we want. What we really want to do is we want to be tilted fixed with a fixed angle to an axis, and this is going to give us the ability to specifically define an angle that's relative to an axis. It's not relative to the cutting direction. It's not relative to our UCS or the origin of our part. It's going to be relative to an axis of the machine, essentially. So we're going to put this at the z-axis. I want this thing to be straight up and down as the number that I want to work off of. And that angle that we're going to put in there is going to be 45 degrees. So let's take a look and see what the result is using this option. Okay, so our path has been generated, and we can now see that all of our leads are a uniform 45 degrees. So if we backplot this and we step this through, we can see that our tool is tilted up. We're still cutting with the ball, which is exactly what I want, and that tool is still staying perpendicular as it sweeps around the part. So this gives us the ability, without creating complicated tool tilting strategies, a way of defining a fixed angle where we want this tilted at 45 degrees, and it maintains that 45 degree throughout the entire path. And this can be useful in many different situations, and it really gives you an easy way of creating a tilting strategy that keeps that tool oriented the way that we need to keep it from violating any fixturing or parts or so on. So it's a very, very simple way of accomplishing that.